All attendees are in listen-only mode.
Hey everyone, this is Justin Bonfili, and I'm joined here by Paul Larter for today's webinar to go over some tips and tricks in Autodesk Moldflow Adviser. As usual, your microphones are muted, but if you have any questions or anything, please feel free to post them in the box as shown. And we have a couple others in the background that can help answer any questions. We will also be posting this PowerPoint presentation to the public folder listed down below, which is autodesk.box.com/moldflow31. Just wanted to begin, I wanted to highlight some past and upcoming webinars. We've recently had webinars based around the newest version, which was 2018.2, and some of the main features that were added, such as centerline extraction and the new bubbler and baffle modeling. In the near future, we'll have a webinar on setting up and utilizing custom databases within Moldflow, and also what's new in Moldflow 2019 sometime in April. If you're not able to make it to a webinar, just keep in mind that they are all available for replay on our YouTube channel listed here. And if you're not already signed up, feel free to sign up through any of the options listed here. Here's a quick summary about our knowledge website with articles that are created by our technical support specialists here at Autodesk. These listed here are just a couple of the recent articles that were created, and you can sort by the most common troubleshooting articles by going to this link here. As far as the most recent release, it is Moldflow 2018.2, and it should be available in your account. If it is not, please reach out to us here in technical support and we can provide a link to download the most recent version. For today's webinar, we're going to first go over the Moldflow Adviser trial that is available for those that either do not have Adviser or are not up to date and want to try out some of the new features added since 2018. We'll then go into some tips about the installation and common issues. Then we'll finish off with a demonstration by Paul, and he'll go over some tips and tricks that may be useful in the use of Adviser. Feel free to add questions in the box if you want to see anything specific, and we'll try to get there if there's time at the end. Now on to the trial. There is a 30-day trial available for Moldflow Adviser Ultimate. It's only available for 64-bit Windows, and it can be downloaded by going to this link here, which is autodesk.com/product/moldflow/free-trial. After downloading and during the install, you'll want to install it as a standalone product, and you'll enter all 9s in for the serial number and then add in the product key shown here. After the installation is finished, you'll receive a pop-up about how many days are left on the trial, and if you want to run it as a trial or activate the product into a full version. This link at the bottom explains in more detail about installing the trial and also how to upgrade from the trial to a licensed version. Now, on to a little bit more about the Adviser installation. We've recently switched over to offer just 2 versions of Adviser, which is Premium and Ultimate. The main difference is shown here is the Ultimate version includes everything from Premium, but also the runner balance analysis, packing, cooling, warp, and fiber orientation. After installing Adviser, the extracted files that were used for installation can be deleted if you'd like to free up some space. The default extraction folder is C/Autodesk, so if you navigate there, you can delete those folders. But one thing you don't want to delete is the Network License Manager folder, because that could be where your license file is kept. One common issue that we see a lot is if you're able to run Adviser, but you're running into issues with jobs getting stuck in the job manager, or they're not progressing, or the mesh gets stuck at 40%, it could be an issue where the PC name in the system settings does not match the name that is in the registry. There's a link here that goes into a little more about this issue, but the easy fix is to navigate to the directory here in the registry editor and modify the names in the active computer name and computer name directories to match the PC name in the system settings. The names must match exactly, and they are case sensitive. So you see here, the computer name in system settings is all capital, but in the registry, it shows as desktop. only the D is capital, so you could run into an issue there. I'm going to pass it over to Paul now, and he's going to demo a couple tips and tricks from within the software. And again, if anyone has any questions or wants to see anything specific, please feel free to ask in the box and we'll try to get to it.
Thanks for that introduction, Justin. Hello, everybody. So I'm just going to go through a few hints and tips of common things we see with advisor questions coming into support, and some of the what are sort of low-level things that customers may not be aware of, and how the software works, and some little tips to make your life a lot easier with the software. The first thing I'm going to just show is the help. Now, when you start the software, a lot of you might see this message as shown on the right. What you need to do here is actually go to the drop down at the top and download the offline help. This takes you to a web page which downloads an executable which you run, and that will install the help on the computer. Now, most of the time it will install in the latest directory, which would be under your documents, my projects, and it's not there, the help. One sec, it will be under, let me show you. If you go to options and the help system, it will be under see program data, Autodesk. Now, what will happen sometimes is it may not necessarily put it in the latest release, so just make a note of where it's installed. So it will be in either in 18 or 18.2 as on this machine, and then you just click on the help, do apply, and now you have offline help. You can also switch back to the online help. So that causes a few support cases because of where it installs by default. So just have a look in all your 18.0, 0.1.2 directories. Right, let's go up to the, just do a quick overview of the preferences. So under the application menu, if we go to options, this is where we can change various things. Currency, of course I'm in the UK, so I like to have pounds. Directories, this is where your project always starts. So by default, it will be in your local document area. But if you're working on projects all the time, like myself, I have a directory called D support. So you can change it there. So you just hit these three dots here to browse to where you want your project to always open. So when you go on to new project, it will go to that directory. It just saves a bit of navigating. Back to options. Mouse mode. Most of you probably have navigated to this screen. This is where you can set up how you control your mouse. So I have a particular order. I never use the quick menu down the right. I probably don't even know how to use it because I always have my mouse set up. I never use any buttons to control the model. So I normally have right is rotate, middle is center, band in zoom, and fit to window. That seems to be enough for what I need to do. There's been a lot of complaints over the years since Advisor came out that our scrolling of the mouse wheel always went opposite way to any CAD system. We can actually now reverse that. So with the wheel, you can actually turn on the reverse direction. So when you roll your wheel away from you, your model goes into the screen rather than coming towards you. Another strange thing with the software that's never done by default is the results order. Whenever I'm doing support cases and on customers' machines, there's two things that make it look like I haven't been using the software for as many years as I have. That's one, that everybody's results are in the order they've installed the software with, which is not alphabetical, so I can never find the result. And the mouse modes, the mouse modes are normally not set up, or they're set up to the customer's preference, so I always have trouble navigating the software, which is quite embarrassing at times. So how to get these in alphabetical order, you just go to the results page and click on this button here that says order, and it's as simple as doing alphabetical. And then again, you will do the same, say, for your core results and warp, and then so on, whatever ones you want to do. And now, not in this session, but next time once you've closed down Adviser and reopened, then the results for any studies that have already run will be alphabetical order. Another new feature in Adviser, and the same as in Insight, is the option that when you do a save as or a duplicate of an existing study, up to now we've included results linked from an original study. Now sometimes that can mean that if you've run study 1, got a set of results, you then change a condition like a process condition or some other factor, you can find in some instances that study 2 has got a link to study 1 and things may not run, or they might take preferences from a previous study. So I prefer to change the duplicate study to do not include any results. So if you do a save as or a duplicate, your copied study has no link to the original. You can, as well, under results, have a second set of units. So I'm working in metric, but if you want like your pressure results in megapascals and bar, you can set a second list of units when you display that result. The viewer is an older thing that we used. Some of these options are probably not used in this release, but you can change the shading of the model. If you have some graphical issues, you can turn off OpenGL. Most of the time we don't touch this tab. The reports tab. Again, this is the default if you're going to create the report wizard. But nowadays we use a different method to do reports. We can make the results on the screen. So we can set up the defaults for the document and how it's displayed. Internet. So if you don't like that community page starting when you start the software, you can turn it off or have it launch into an external browser. Help system we've already covered. And the other one that's sort of useful maybe is the backgrounds. You can, if you want, change your background picture. So by default, I think it's on Logo. I've been messing around. So this is the background without the model. We could have the system default, which is nothing, which takes your windows. Or like myself, sometimes I have a reminder that I've worked for Moldflow for too long. When I started, Adviser was just coming out. So 1997 is when I started, and version 1. I can't quite find the CD for one. But yeah, Adviser's been around for a long time. So that's just a way of changing the background. We can also do things with the model. So if we now open, that's the preferences. So hopefully if there's any questions on that, mark them down and we can come back to them later. So now I'll just open a model. So just going back to the preferences. The other options is you can change the colors of things if you fancy to have a different background on the model. So that's what those other options there do. I don't like actually doing that because it gets a bit blended in with the model. So here we have a model. So what I'm going to just show you here is something in the process settings. Most of the time people will go into the process settings and click on the first tab. You may change your material, the process, but right at the end we have this accuracy. By default we run on level 0, so that's the size of the mesh. This is good for a starter and for models that are not too complex. If you start having models that are got more features on them, like especially a big model with small features, you may want to play around with these different levels. I'll show you what actually happens in the background with these levels, but it basically makes a finer mesh. and it can sometimes affect results. Level 0 is generally okay for simple models without too many features, but you may want to sort of practice or do an experiment where you change it to level 1 or 2 and see if there's a big difference. If you find there's more than a 5% difference in results, say from going from level 0 to level 1, then you might think it's better at level 1. Then they do the same again and run at level 2 and then compare. If there's not much difference between level 1 and 2, then you're safe to go at level 1. But saying that, the difference between level 0 and level 2 is not much compromise in analysis time. I'll show you in a minute the different analysis times for this simple model between 0 and 3. There is a great difference in the mesh density on level 3, so that does take a long time. So that's probably very rarely used, and it's probably not going to increase the accuracy of your results that much. So here we have a model. I've run it in at level 0. We'll just turn on, say, the fill time, or maybe even the pressure will be something to compare. Now, another feature is if I then open a second model, and I'm just going to turn the dynamic help off to give a bit more screen space. So again, under the user interface is where we can turn different features on and off that we don't need. So just turn the help off. So when you've got two models open, you may be used to going to view, tile vertical. So we want to compare these to analysis. We also have the options here to lock things. So we can lock all views. Now, this is good with the same model. If you're bringing in two different models to look at, you might find the rotation points are different, so it doesn't work as well. And then we can lock all plots. So now we can start comparing results, so we can see the difference between level 1. There is a slight difference in the result, and we're going to have a look at the other results. Now, another feature, rather than going through and opening the third model, tiling, and locking all the views again, there is an option that if you just grab the model, I might even be able to grab two, I've never tried that, but if you just grab it and drop it on top of an open model, it will do all that work for you. So again, I just will have to quickly tile, and it's automatically set the same result for the one you dropped it on and locked all the animation, the result, and the view. And then we'll just grab the third one. So now we've got all four open. And now when we tile this way, it will do it as a 4 rather than what you ask it to do. So here we can see it's a simple model. We haven't got a great difference. The pressure drop is decreasing as it's going on, a slightly finer mesh. And just a quick summary, if we look at the summary and look at the... Why am I not getting the summary up? Is it? Right, I think it's because it was shrink. Here we can see, if you just click on fill time, we can see the analysis time. So level 2 was 124 seconds. I think level 1 was about 30 seconds. So that is an increase, but it's not a great increase. However, if we look at the analysis time for here, we see we've got over 1,000 seconds. It's a great increase. So most of the time, you should experiment maybe. If you've got any doubts about the accuracy of the model, or you feel let's just try another level, just maybe go up to level 1 and 2, see if there's a difference. If there is a big difference, like more than 5%, maybe just run it at level 2. You may want to try level 3, but I don't think it's really, from experience, I don't think that's really necessary. Have we got any questions so far? Justin or?
We have, but it looks like everything is being answered so far.
So the other thing I'm just going to quickly do now is show a little more, not a more complicated model, but a bigger model. The only reason I'm going to show this is because I've taken this model into Insight to show the mesh. So we've got housing 1, housing 2, and housing 3, and we will tile. And I think if we look at 0, the analysis time on this was 64 seconds on my machine. Yet the summary for this one was 2090 seconds, so a lot longer. And again, you'll see even with level 2, it's not a great deal greater than level 1. So for most people, you may feel that if you never use the accuracy, is to have a look at increasing the level to see if the results change. If they don't change much, then keep it at level 0. There's nothing wrong with level 0. But I'll just show a quick picture. So these 3 models are sort of around the wrong way. I'll just switch them back. I've read these 3 studies into Insight. So for those customers that have both Advisors and Insight, if you want to see what Advisors created, you just open them up, the study, and there we can see. So you can get an idea that, yes, maybe the saw housing mesh, especially for this part, it's got a few smaller features than the overall size of the part. It's possibly, I would say that's a little too coarse. So housing 2, which is level 2, is, I would say, acceptable. That's probably an ideal mesh for that type of analysis on this part. And then you can just see with housing 3 just how much finer and that is. And for sizes, there's about 15,000 elements in housing 1, or the saw housing at level 0. In housing 2, there's around 36,000. And then in housing 3, we've got 116,000 elements, and this is dual domain. So quite an increase. And housing 3, I think, is a bit too fine. You want something in the middle, really. So that's that. So that's that part. Any questions on that, Justin? Are we okay for the accuracy?
Looks like we're still good for now.
Good. I'm not sure how many people on the call are Advisor users. So now I will probably go into just reading in a part and some other techniques. I'm just trying to think what I've got now, and I might import the part again because I've got this one. So let's just find the model. I've got to find where my was it in the reports? So I suppose this part will be okay. So just some other hints and tips maybe. When you first bring the part in, the main thing you really want to get right is the orientation and where the injection location is on the part. We're probably not too worried where it is in space. It's only when we're going into single cavity or multi-cavity that you really then need to put the part relative to 0, 0, 0. Now everybody works different, and I've got stuck in my ways over the last 21 years using the software how I work. I probably don't use all the newer features. I especially don't use anything automatic in Advisor, because generally I want to model a tool system that's sort of designed, and we want to prove that tool system rather than letting Advisor come up with a tool system. So these are just some things. So what I would generally do is, first of all, make sure we click on the front view. Well, I can't see my icons because of the interface. That's okay, now I'm there. So normally I like to look on the front view like that, because looking down on the XY plane from the positive Z is your projected area. So if you're not happy with the rotation or anything of the model, we will go into geometry, select the model, and we will rotate it. So I'm going to just rotate it around the Z. just deleting results, that is. And so I'm just going to have to change a mouse mode. I've got so used to the mouse not using the reverse direction that it's, yeah. So if you want to know where this gate location is on a face, I don't know if this is the right way, but I sometimes I use the measure tool. So I click on that face and I can see where my Y is. My Y is at minus 61.02. I click on that side. I can see it is at minus 11.02. So that probably means the part's 50 mil wide there. So then if we want to get this gate accurately in the middle, where at the moment it probably isn't, we can look at the figures and then change things to be more accurate. So what I might do is then go into, close that down, pick on the injection cone, right click and properties, and then we can just tweak the gate location. So actually that is 25 added to the 11.2 is in the center, but if you want to tweak things, this is how you can do it. If you're not so happy that the X, well, the X we can't change because that's on the end, but if you want to change the Z slightly, make that a rounded figure, you can just go in and tweak it. So at this stage, what we're doing is just getting the gate location correct on the model relative to where it's going to be in the tool. Then we'd run the analysis. So I use that quite often, the measure tool, just to investigate a model where faces are and see where the model is in space. Now, at this point, I'm not bothered where it is in space. My only concern is where I want the gate location to be correct on the model. There might be other ways to do it, but that's the way I've always played with the model. So now, and the other thing is we can move the injection cone. If you just go into injection cone mode, if you just click and hold on the injection cone, you can actually drag it over the model. If you ever get a large injection cone, it probably doesn't apply in Adviser, but sometimes if you get a very large cone, it means you might have moved something away, a feature away from another feature. So the injection cone is actually relative to the size of the model. So probably if I made a duplicate of this part, so I've got two parts and moving far away, your yellow cone will increase in size. Let's just close that down without saving. And so I'll show some other features. So this is just a badge runner system I've just put on a model to show like some problems that come up. You go to run this analysis, you've modeled your runner system, and I'm going to go over again how to model something like this, how the yellow cones and the parting plane all have a link to each other. So if we go and start analysis, you may have seen this message. You should resolve the following issue before running your analysis. So the runner system is not complete. Each gate must come from a sprue, which means I've done some bad modeling. So under view, we've already looked at the user interfaces where you can turn off a few things like the view cube, the navigation bar. It's always good to leave the ruler on just in case you bring the model in the wrong units. Is the visibility of objects, and there's this runner center line. This is very good to see what you've got, and also when you're building a runner system, I tend to use this quite a bit to see the intersections. So turning that on, we can now see where the intersections are. And again, I'm just going to turn off for now the injection cone, and we can see over here on the right we've got a bit of a mismatch. Now, another feature you can use to check your runner system is just go into geometry and move runners. And this is what I tend to do with customers models. You would pick something and make sure it moves as expected. And then I just do an undo to put it back where it was. And again, we can do that one. That's all moving. So we know that bit. And then we move that down here. And it's not wanting to move. It's not playing ball. And we can see the problem, that it's not connected. So that's why we get the error message. We could see that from the skinny runners mode, where we could see the center lines and see there was two ball joints. Sometimes you are able, depending where the runner is, but the runners tend to follow a certain line and it may not always snap. So actually the quickest way to fix any problems like this is just to select your runner, hit the delete key and model it again. Now you should have this snap to runner turned on and you should get these nice yellow icons when you're on somewhere properly. So here, be careful. When you're doing runners, it's also best to turn off, go back to view, turn off your injection cones, because we can see as I'm hovering, over that area, I'm getting two icons sometimes. That I'm actually connected where I want to be, but depending how I catch the model, it's not doing it now, it may snap to the bottom of the yellow cone, so it will actually be there to there. So that's another thing. Once you've got the gate on the part, we don't really need the injection cone anymore. So you can turn that off, and then we just snap there, and then I should be able to snap there. As long as you see that yellow ball on the end, you know you've got a connection, and then we'll be fine to run. I tend to keep with geometry, we keep the defaults the same, and you can always just right click properties and change sizes afterwards. So we can just go in and change. So now I will show you how you can build a tool like this. There are various ways to do it. There's automatic ways and manual ways. Generally with this would be in a free plate tool where you would have a floating plate in the middle, but that restricts you a bit how the software works. So if we just go to the view tab and look at the mold outline, you can actually see I've modeled this in a two-plate tool. And at this stage, when you have your tool drawing, now what you want to do is know the relationship from your yellow cone to the bottom of the spoon. So when you have a part, you just work out on your tool drawing where the bottom of the sprue is in relationship to where you're injecting in the part, and then we can model everything in between. So if we start afresh, so I think the best way is probably to pick everything and delete it. Let's hope I've got my cones turned off. Turn my injection cones back on. So the first thing you may want to do, I'm just going to tweak these runner locations. So maybe let's just so I do some changes, I'll change that to 30 to see where that goes. That goes down there. And I'll change that one to 30. I can't change the Z because it's sitting on that face. But at this stage, you may also want to look at your tool drawing where your split line is. So in this case, that's, again, we use the measure tool. Pick on this face. So we can see Z is at minus 0.51. So what you would do is go into translate, pick the part, and I will plus 0.51, apply. Now if this was a two cavity tool, you'd sort of want to also move this part so it was in the minus X and then the other side to the plus X. If you need a demo of that, we could possibly do that afterwards, but for now I'm going to stay with the single cavity and just do a couple of drops. So basically now I am moving my component, the part, to the correct place just to make my life easy. So here we can see Z is at 0. I'm not going to bother too much now about the X and Y. Then we now set the part in plane. So by default, the software normally goes on the top of the part. So if we created the mold now, that's where it would generally go. And what you need to remember with how the software works is the A plate is your sprue height. So you look at your tool drawing, decide on your sprue height. Now, if I want to make that same run layout as before, my parting line is too close to the part, so I will just say move it up 25 mil in there, and that's So now I'm going to have a sprue in the A plate, and then I'm going to model what I want between the bottom of the sprue and the gates, and we can model whatever we want. It can be as fancy as it gets. So we do close to that. We just set the mold size. So the only real important thing here is maybe the A plate. Again, if you're doing cooling circuits and other things which we won't cover in this demonstration, you can increase the overall size of the tool. So here I'll just set 25 and close. And the only thing I like to model automatically is the sprue. When you click on sprue, the software puts a bounding box around the part. So if we go to bounding box, this bounding box here, well, in fact, it's the tool. Before you do a tool, the bounding box center would be the drop point. When you have a and B plate, it looks like it's going to be in the middle of the A and B plate. So we go back here, and I think I needed to change my Y just so I've got the Y dimension on the same plane as my gates. I'll set that and close. So that's the only thing that's modeled. We can change the size afterwards. Now I don't really want to see the mold outline. So now I'm going to model everything as per my tool drawing. Now tool drawings, the runner system's quite simple. It's just a matter of knowing your X, Y, Z for all your intersections. So here we're going to just work blind. So we go back into geometry in gate. Now the thing with gates is the software follows rules. So I'll probably show you how the rules work on another model because I've already gone a bit too far on this one. So if we just click on here, you can see what's going to be made. So in this case, we're going to have a vertical gate, 3:1 circle, and these dimensions. That's fine. So now if I go here, you can see it automatically defaults to the 2 injection locations. And if I do apply, it makes my gate following rules. And the rules are the start of the yellow cone to the parting plane. And in our case, the parting plane's up there, which in our case, we don't want. So if we do an undo, again, we select which location we want, and we define by relative dimensions. So here, I might want this gate 5 mil up, and do apply. And now it's automatically snapped to the other gate because it knows there's another one to make. And this one, again, we do relative, and I'll just put in a different dimension just to show you the mechanics of how the software works. Apply. So now we've got 2 gates, so we're ignoring any automatic rules now. At this point, I will turn my injection cones off just so I don't accidentally snap to them. And now we can go and model the rest of the runner system. So we can click on runner, click there. Again, you can display a grid and snap to grid, but again, they're just to aid you in making things a bit easier. I will just snap over here, snap here, and snap there, there to there, there to there, and there's my nice runner system. Again, I didn't do that too perfect because now I will go back into my, you don't have to go into skinny mode, but you can sort of see the intersections. And now I will just tweak these. So again, I should just go and check where that was because that's straight up. So that's at 24.5 and 30. So if you just go into properties, I need to go in again because it was already on there. So X was 24.5, Y was 30. Of course, we don't change the Z because we're up in that height, but you can. If you want to sort of make a staircase going up, you can do that, as long as you model all the sections quickly. Again, we click on this one, and I guess that one was around 90, I'm not sure. I'll click there, 35. Nope, it was 30, wasn't it? So basically, a quick way to do a runner system is just look at your tool drawing, write down quickly on an A4 piece of paper, just write down all your X, Y coordinates from the bottom of the sprue. You need to know where your datum is. In our case, 0 is on the top of this part, the top of the bottom of the sprue is 25. Generally, though, you'd make the bottom of the sprue 0, 0, 0, and then everything else is worked out from there. But hopefully, that explains that you can create any sort of runner system. It doesn't matter how complicated it is. I know I've made this one simple, but it's those bases for getting a quick runner system on the screen. Just sketch it out, sketch the sections, make sure you've got enough intersections, and afterwards go and tweak them all to bring the thing into place. And let's just turn on off skinny runners and the mold outline. So any questions on that, Justin? I'm just going to move on then to just showing how the mouse gate location works relative to a model. Not that one.
Yep, no other questions yet.
That's good. I think there's just a couple more things to show. So here is just a part. Another option we can do before I go too far with this part is we can actually, whenever you got a model and a runner system, you can actually save out the runner system. You can export it and then import it later. So for this part, on the feed system drop down, whenever there's a black arrow, that means there's more things hiding under here. We can actually, whoops, the first thing I need to do is change from part only into single cavity. Again, it puts the bounding box to make sure you're pointing the right way. I like to turn these things off. Is we can go into geometry, feed system, and then we can go and find the feed system. I need to remember where it was. I think it was here. No. Advanced tips, I think. Yeah, so here is an already modeled runner system. You do open. Of course, for the demo, it's going to put it quite close. And so you can import a previously made runner system. So you could have a library of runner systems. The only thing it won't do, I believe it doesn't do, is put the gate on. So because you're not going to, it's never going to connect automatically to the part. So all you have to do is go down to gate. Again, it's if we look, it's highlighted that one first. Again, it's trying to use gate properties, which I'll explain in a minute. So if you just do define by end coordinates, we should be able to pick and get that nice bright icon to show that you are connected. And then we zoom in. And again, it's automatically gone to the next injection location. Again, we're still on there. And we click. So that's how you can import another runner system. So I will just close that down and open up again. Close that. Cap. So let's just show you a bit of the logic behind gates, because it can get, this is because the software uses rules to automatically do things. So if I now change my part back into single cavity and turn off the bounding box, go into geometry, and we'll set the part in plane. And we can have that probably at 0 to start with. Okay, so now let's see if we go into do gates. If we do gates by the rules, here we've got a vertical gate. I need to just rotate my part around. Here the rules are vertical gate 3 to 1, a bit like before, because I haven't changed the defaults. If I do apply, you can see we get apply again. We get that. That's because the software is following rules. So if we just do an undo and an undo, if I go in here and change that from a vertical to say horizontal by length, and here it's set to 10, we can change that, but leave it at the default. What the software does, it comes out 10 millimeters from the yellow cone and then goes up to the parting plane. So that's the rule we set for the gate. We'll set 1, do apply, and we can see that's happened. So that's because it's following rules. Now, to show that's how that works, if you have this parting plane higher, the gates will still be 10 mil out, but they will go higher up. So again, we go to gates, injection location 1. I think the rules are the same, horizontal by length. So you can see it's still gone 10 mil up, but higher angle. So that is the logic behind how gates are created, which is, again, if you're trying to create your own runner system based on a drawing, you probably would only ever create the sprue in the model and manually, because you know where the gate joins the part, you know where its endpoint is. It's so much quicker to sketch up what you know. So that's that. I think I'm coming to the end of it now, Justin. I'm just trying to think, is there any other things we need to show? Because I can see we're nearly at 10 minutes too. There's probably other things I needed to talk about, but at the moment...
Yeah, it doesn't look like there's any questions. We can wait a couple more seconds to see if any come in, but if not, if anyone has any questions at a later time, there will be a YouTube video of this webinar posted, and you can just comment down in the comments on the YouTube video.
And if there's any features that people want a bit more detail on, they can always probably put a few notes, and we can always contact them just to discuss further if it's been of interest. I don't know how people normally get hold of us. All right, I think that's it for now. I think we're getting near the top of the hour. If you want to take back now and then just finish off with the final slides if there are any.
All right, thanks a lot, Paul, for that. Looks like one question just came through. Is there other Moldflow webinars I can access? This is great information. I would like to view more Moldflow tutorials. There actually is. If you go to our YouTube channel, there are all of our past webinars, and this one will be uploaded as well. And down there in that link that's shown, you can actually download this slide deck and past slide decks as well from going to that Autodesk box. Any other questions? If not, we'll wait a couple more seconds to see if any come through. All right, looks like no more coming through, so I guess we'll end it there. As I mentioned, this webinar will be uploaded to the YouTube channel, so if there are any additional questions, feel free to comment on the video. Thanks, everyone, and have a nice day.